Find the real zeros of the polynomial function. Use your graph or the location principle to help shorten your list of possible rational zeros.
All right, so we have a quartic polynomial this time, and so we should be expecting to get 4 zeros. And if I look at my table, already I should notice that 1 is one of them. So before I even start this, I'm going to see if I can just divide out synthetically the 1 and then have a slightly easier time with this problem. So 1 on the outside of the box, 12, negative 28, negative 63, 37, and 42. Bring down the 12, then 12, negative 16, I think, negative 16, I think again, which is 89? 79, I mean. Where's my eraser? 79, negative 79. I'm going to go with negative 42. I'm not even going to do the math. I'm just going to assume that's what it is. Okay. All right. Well, did that simplify things? Maybe a little bit. It broke it down to a cubic, but my factors are exactly the same. I got the 42 and I've got the 12, so I still have to list out all those factors. Ah, geez. Okay. So I've got factors including, let's say, for 42, 1, 2, 3, 4 doesn't go into it, neither does 5, 6, 7, 14,
Yep.
and 21, and I think 42. And then for 12, we've got 1, 2, 3, 4, not 5, 6, and okay. So it's all of these divided by all those. So I'm going to pause here for a second, list out all of those possibilities, and then continue with the video. All right, so here's all the possible rational zeros, and I'm going to use the table of values and the location principle to help slim this list down. So if I look at the table of values, I'm looking for where the y values go from positive to negative or negative to positive, and that's where I would have a possible zero. So looking from left to right, I go from 132 to negative 18, so I know there has to be 1 here. I already have 1 at 1. It was given to me, and I synthetically divided it out. And let's see, where else might I have 1? In between negative 18 and 42, there's another one. And then the last one is between negative 192 and, and 462. Okay, so let's see if we can go through this list and cross a couple of these things out. I've already done 1. That's been taken care of. It cannot be 2. It cannot be 3. Cannot be 4, 6, 7. It is possible that it is a half because that's in between negative 1 and 0. 3 halves is also a possibility. 7 halves is 3.5, so that's a possibility. 21 halves, not going to happen. 1/3, maybe. 2/3, maybe. 7/3, 2 and something. No, I don't think so. It's 2 and how many thirds? Yeah, so that can't happen. 14/3, nope. 1/4, maybe. 7/4, 2 and 3/4. 1 3/4. 1 3/4, that's a maybe. 1/6 is a maybe. 7/6 is a maybe. 1/12, yeah, and 7/12, yes. Okay, so now it's going to come down to getting lucky, and hopefully you do get lucky. I know I did. Anyway, that was awkward. So I'm going to go ahead and try. I'm going to try a negative 3 halves on this. Okay, so bring down the 12, and negative 3 halves of that is negative 18. Please check my math as I do it, because who knows if I make a mistake. And then that makes a negative 34. I'm going to go with 51. Subtract this, negative 28. and a 42. Oh, so satisfying. Okay, so now I've got it down to a quadratic. All I have to do is factor that quadratic if it is factorable. But first I'm going to divide everything by 2 because they're all even. And then I've got a 6x squared minus 17x minus 14. And then I'm going to try to factor that thing. I'm going to go with a 2x and a 3x in order to multiply up to 6x squared. And then for 14, let's try a 7 and a 2. So inside I've got 21x. On the outside I've got 14x. If I subtract those, I would get 17. And I just need the bigger one to be negative and that one positive. Alright, we are almost done. So now all I have to do is list out all of my answers. X is equal to 1, negative 3 halves, 7 halves from this set of parentheses, and negative 2/3 from the last one.